hello, Brad. Okay.
And just a
Um,
quick
yeah.
question as well is that is there a YouTube videos of all the different ones? You said we're gonna make YouTube videos from them. Is that right?
Yeah, but I have so far for the last one um, for the last one I sent you the recording as a link to the recording. I'm not sure if that works for you. Can you see that?
I couldn't get it to play on my system. I don't know why.
Okay, that's not good. Okay, and then Brad recorded all the sessions we had so far, right? And I still have this on my desk here. I have to get it to Rob to make YouTubes out of it. If,
That would be the best for me because I can get YouTube's pretty well. Is that possible to do it that
yeah.
way?
Yeah.
Okay, thank you so much.
Yeah. Okay. I'll do this. We certainly we do that. Yeah. No problem. Okay. So hello everyone. We're complete now. Brad, I just a half an hour ago I sent you one test back. I'm not sure if you saw that. And I'm working on the other one. Sorry, they fell a little. They got lost, so that's why I'm so late on getting them back to you. But I'll get the other one back to you today. Okay, so today we wanted to talk about maps and not maps. Really, in aviation, we talk about charts. And so this here is my chart. Oops, it's really blurry. Sorry. Oh, there it comes. Yeah. And on these charts, there are a lot of the legend is on the outside. Come on, focus on both sides. And I hope you have your chart by now so you can work on the legend and also work on the chart. And send you a bunch of chart questions. And how did you make? And those are questions we're doing now. We're talking about now the chart questions. And how did you make out with those? Okay, or was it all over your head? Okay, I see thumbs up. That's good. Greg, you took a look at your chart. Okay, very good. So gave you a little task there, and it was okay. So this is the VNC, which stands for Visual Navigation Chart, and it's a 500,000 to 1. So question number one was 1 millimeter on the chart. How much is this in nature, in reality? Who had a problem with that?
0.5 kilometers.
Pardon?
0.5 kilometers. Is that
Point
right?
0.5, 0.5 kilometers. Yeah, 500 meters. So going the reverse, 1 kilometer in nature is 2 millimeters, right? And that's a good thing to know. So when you, for example, map out your 50K flight, it's a 100 millimeter stretch on with a ruler on the chart. Okay, well done. Then you found SOSA, I guess, and you found the coordinates. And as you know, coordinates go in, we usually start with the latitude in degrees, minutes, and seconds. So has 60 minutes, just like with the time, and each minute has 60 seconds. Easy to remember. And typically, the way we express coordinates, we can either really express them in degrees, minutes, and seconds, or in degrees, minutes, and decimal minutes. So basically, behind the minutes, there's a decimal, and one decimal is usually enough. And the coordinates for SOSA on the SOSA website, by the way, but I figure you measured it out of the chart, hopefully. coordinates are,
So,
uh, pardon, who can read them to me?
so
Jimmy or Greg can.
okay, I got my own. Yeah, so I got 43 north, and I got 18 minutes, and 80 west 20 when I actually use my ruler to do that. Now, what I find very challenging is keeping everything really straight and not going off a little bit, and
Yes.
so
What
I'm off by a
really
little.
what really helps is if you have sort of a tool like this, sort of a protractor. This gives me, it's a triangle, and it has sort of in that circle I can measure any angles, right? But it's also good to just go with a 90-degree angle so I can move up and down the longitudinal thing until I have my latitude, right, and project this out onto the map, and also the longitude. So that's a it's a good thing.
I just
Um,
I just used a piece of paper.
yeah, you can use a piece of paper, and you can also actually, I found a website, you can print your own if you don't want to buy it. I think buying or having a plastic protractor is better because they're transparent. But if you don't want to buy it, you can actually print one from a website. There's a website called Printable Protractors, and you can print that there too. It's sort of a PDF file, and you can just cut it out.
Where's the best place to buy one?
Oh, school supplies, I would say, or Amazon, right? Amazon is, you order it today, you have it tomorrow. It's really nice.
See, right now I'm in a rube. I don't even have I couldn't get a ruler.
Okay, you don't have a ruler?
I,
Okay,
I I didn't bring one with me. I just have trouble finding one. My wife just found me one just an hour ago, so that's good.
yeah, you gotta dig deep in your drawers, your old drawers, right, from way back when,
Yeah.
or your kids' school stuff. It's in there too. Okay. By the way, for the exam, um, if there's chart work, they will give you a chart. The chart could either be Ontario, from what I've heard so far. Maybe they changed this now. It's either Ontario or sometimes it is Western Canada, Alberta. And quite often, this is actually what comes up is Red Deer. Red Deer is north of Calgary, between Calgary and Edmonton, and it's a pretty big airport. We flew Canadian nationals out of it once, and but not very busy, right? It has a Class E control zone. I think it's quite interesting. So that's a control zone where you should be talking to somebody, but there's not necessarily a tower there. And if there's no tower, then you basically handle it like SOSA. You call Red Deer traffic. I'm coming in, just as you call SOSA traffic. This is basically broadcasting what you are doing, and hopefully somebody else who is also on the way to land there will hear you, and you can talk to him, and you can figure out who is first. Okay.
Question about that. Do you know if the charts that they'll give us will have a legend included?
I don't know. That's good. This is a really good question. Yeah, I should make a note of that. It could be that just they just give you a piece, right? So let me just note this down.
And we're allowed to bring that protractor with us.
Yeah, you can bring a protractor. You should bring a ruler. You should bring a, the best is not a ball pen, but a pencil. But keep it sharp, right? Maybe have a sharpener there, so you or and quite. I've heard different stories. They sometimes give you everything you need, but in other times not. And it's good to have a piece of paper on the side if you need to figure something out. If you go to a Transport Canada facility, quite often you do the test on a computer, right? So you basically you go click 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 click, and then it's good to have something else where if you want to work something out, for example, you're doing the true to magnetic or so or compass, You can just write it down. So having a piece of paper on the side is a good thing. They will probably give you one, but it's good to have just in case. Have one in your bag. Basically, bring your own map. You bring your map in your bag as well. You can do that. And if, for example, if the map they are giving you doesn't have a legend, and you have your own, there should be no problem if you look at your own map and look at the legend, right? There's a few things you need to. We'll talk about the legend then. There's a few questions. One of the questions is always how are, or is frequently been there, how are heights indicated on your chart? And the answer is there's contour lines and there's tint. You need to know that. And if you look at the page where, yeah, just look at the, it's not the, there's basically two on the outside. There's two pages, right? There's the one where all the other charts are on there, and on the back it's a little different. This doesn't want to focus in. If you look at this, at the sort of at least on my chart is a little older. At the right lower part, there are the hyper. Holy smokes! The hypsometric tints. I guess that means the altitude tints, and they give you a range for every chart. Now in Ontario, there's not much. I mean, there's no mountains, right? So it's pretty simple. I mean, we are basically going here between white and green and white, and so everything up to 1,000 feet is green, and then above 1,000 feet, it's a different color. It's white, I think. But if you go out west, right, where the Rockies are, this is a whole different ballgame. So let's have a look at how this looks out west. Okay, I'm going to. Oh yeah, we also wanted to record. Sorry for that. Didn't follow my checklist. Okay, just okay.
I noticed some. The U.S. maps are somewhat different. Is that right? Are they much different? I know they have different. They have different colors and stuff like that too as well.
No, the US maps are generally very similar. They may have a little different color, but they're generally quite similar. And what the Canadian, particularly the Toronto map, has a lot of detail. I think it has too much detail, and therefore it's sometimes just too difficult to find something. Like if you really want to find, looking for some information, for example, airport information, what is the elevation of the airport, it can sometimes disappear because there's so many other things right on the map. But anyways, let's look at elevations first. So I'm going to share something now. Sharing my screen number 2, and I'm also recording just the presentation screen. I think you can see that better then, or it shows better on the recording. Okay, screen 2, share that, and then I usually get a warning. Yeah, ignore the warning. And so this is what you're seeing right now. Here is Sky Vector, and Sky Vector does not have proper Canadian charts anymore because NAV Canada decided to charge them for the information, and they said no thanks. It's an American company, right? But what you can see, so this is southern Ontario here, right? There's London here. You see my cursor, and there's Kitchener here. And what you can see here is so quite nicely, better than on a map with more on it. The longitudinal lines, these are basically those lines. On your maps, they're a little slanted. They go sort of like southwest to north. I think they're southwest to northeast. Well, they're going I'm not quite sure about this now. I would have to have, but they're at an angle because the Toronto map in particular follows more or less the 401 from Windsor up to almost Montreal, right? And that's why the map is not lined up with the compass. So the longitudinal lines on on your map, they're not going vertical; they're at an angle. And of course, the latitude lines are also they're not horizontal; they're also at an angle. Latitude lines and longitudinal lines they always cross at 90-degree angles. You see that here, right? And then they have tick marks. So do you remember the other name for longitudinal lines? They are called
Meridians?
meridians, yes. And the other name for the latitude lines, they're called parallels. Okay. Okay. So, and then you see all these tick marks there. I'll zoom in a little bit to show that better. Okay, maybe a little more yet. Okay, here we go. You see there are tick marks on the longitudinal line. There's tick marks on the latitude line, on the parallel. Now, the tick marks on the longitudinal line, they are actually latitude tick marks. You're basically counting up from, I gotta go back a little bit, sorry. It's too much zoom. Yeah. They're basically counting back from this latitude here. They're counting up 30 minutes to the next line. These lines, the latitudes lines are spaced 30 minutes. So, and 1 degree is 60 minutes. So there's basically every second line is a full degree line. And we can check which one that is here. This is the 43-degree line. See this one here? This is the 40. So this line down here is 43 degrees. Then this line, the next line up here is 43 degrees and 30 minutes. If you count the tick marks up, little marks, then there's a mark that's a little thicker. And then there's one, not thicker, it's longer. Then there's one that's quite a bit longer. That's the 10 minutes. So going up from here to here is 10 minutes. And the next 10 minutes is here. Can you see that? I think you should see it. Can you see it? Yeah. Okay, and then the next is, of course, this would be then the 43 and 30-minute line here.
Do all those lines have markings on them all the time? Sometimes I have trouble finding the markings on them. Do they? Will always say 43, 43.3.
The actual latitude, like where we are, the full degrees have the latitude, like this guy. See that?
Yeah.
And there's somewhere, if you can't find it on your map because it's so busy, then you have to go over to the edge. And usually where the line runs out of the map, there is then, or where it's in a lake or so, where there's more room, they put the latitude, they put the number on, right? But they're sometimes difficult to find. If you know what they look like this, then you know what you're looking for. And this is basically 43, and this is 83. This is the longitudinal 83 west. Okay. So the other thing with these tick marks is that's one reason why I like nautical miles. 1 minute latitude is, Doug knows that, right?
Yeah, it's 60 nautical miles, isn't it?
No, 1 minute latitude is 1 nautical mile. 1 degree
Right.
latitude is 60
60.
nautical miles. That's why I like nautical. The nautical miles is the only non-metric measurement that makes sense because it really um, directly relates to the size of the Earth, basically, right? So a minute latitude is 60 is 1 nautical mile. So every tick mark here is 1 mile. And if you don't have a ruler, you can actually grab a distance here, or if you want to find out a distance and you have a sort of a measuring tool where you can grab a distance, you can measure it here. So it's good to know. Now, there's also tick marks on the latitude line, and these are longitudinal tick marks. So we go from this one, 30 minutes, like 10 minutes, 20 minutes, 30. There's another longitudinal line. And then we go, if we go over here, then I think we saw this longitudinal line is 83 degrees. And then this one here is 82. So it goes the increase to the left, right? Because we're going west. This is 82.30. This is 82. This is 81.30. This is 81. And this is 80.30, and so on. So by the time we get to Sosa, we're at 80 something, like about 10 minutes or so. This here is Sosa. Okay, so what the important thing to remember is the tick marks on the latitude or on the parallel are longitudinal minutes. The tick marks on the longitudinal line, it's the vertical line on most charts, are actually latitude minutes, and a latitude minute is a nautical mile. Do we know how many feet a nautical mile is? A nautical mile, a nautical mile is 6,000 feet,
6,000. I
roughly.
remember I just rounded off in 5 and 6,000.
Yeah. It's 6,000
And 19 or something.
feet, give or take. It doesn't exactly work, but it's pretty much, and it's good to know because sometimes there's questions. For example, you are flying with 50 knots, right? How long does it take you? And you have a glide angle of 30 to 1, and you're 10,000 feet high. How many miles can you fly, or something like that, right? And then it's good to know to convert the feet, the altitude, into nautical miles. So at a glide angle of 30 to 1, if you're 1 mile high, you can fly 30 miles. Kind of neat, eh? And how much is 1 mile high? It's 6,000 feet. And if you go in meters, it is basically from 1,000 meters, you can fly 30 kilometers. Okay, so so this shows nicely, and there's another nice thing that shows on this kind of map better than on a busy map. Within every one of those rectangles here, basically a rectangle that's between 30 minutes latitude and 30 minutes longitude, there's a number. See this number and this number and this number, and this number represents the highest spot in this rectangle. That's what the number. And when the map gets busy, like over here in the US, then these numbers are harder to find, but they're here. There's one here, there's one here, there's one here. And so a large one and a small four means 1400 feet, 1600 feet, 2200 feet. Go back to Ontario is a little higher here, 2400 feet, 2300 feet, and so on. Okay, now we are going out west. So we're zooming out more, zooming out more. Look at all the airports. Zooming out more. Now you see a different tint. It's now it gets into the browns, and because it's getting higher. So let's look at where the higher mountains are. Let's zoom in on this. Okay, that shows very nicely. Okay, can you see? Yeah, you should be able to see that. Okay, so we are talking about peaks, 12,000 feet, 12,800. And you see all these lines around the mountains there. These are contour lines. So these are lines of equal height. Normally you would think it's some kind of an ISO whatever, but in this case, they're not called ISO something, they're called contour lines. And if you look at your map again, at the lower right corner, it says here, I need a light for that. It says here, contour line interval is 500 feet. And that's pretty standard for these maps. So every 500 feet, there's the space between one line and another. And of course, you get the reason why these lines are so close together is because you're going from a river that's whatever low, right, up to a mountain peak that's 14,000. So, and the tint changes as well. If you look at this, the tint here is sort of yellowish, and then it gets brown, and then it gets dark brown, and the summit is 14,420. And here, for example, you see this, bring this up a little bit. This contour line here is and that's the white line. It's not this line, there's a white line here. It's the 8,500 foot line. And then this here is the 9,000 foot line. And then from 9,000 feet on, the tint also changes. So the answer to the question, how are elevations indicated on the map, is tint and contour lines. And when you look at the legend on your map, it shows you for this particular map what the range of the tint is. And in our here in southwestern Ontario, here, the range is 4,000 feet, basically from sea level to 4,000. It shows. If you get a map from out west, the range is something from probably sea level to well, there's mountains up there to 14,000 feet, something like that. When you get into the Rockies, and that's not far from Calgary, right? It's just another 100 kilometers or so from Calgary. And okay, so if you get confronted with contour lines, this is what they are. On our maps in Ontario, we don't see them because they are spaced 500 feet, and we don't have that many altitude. We have one contour line that runs around somewhere where it goes from less than 500 to more than 500, but the lines are not, they only really become visible when you have significant mountains. Otherwise, they're so far apart, you don't even notice there is one. Okay. Let's go back to our map exercise. Or any questions to this? Okay, so, oh yeah, since we're out west, we may as well go up to Canada. Then I show you Again, it doesn't show the map properly in Canada, but I can show you the area where sometimes they'll give you a map for that. Okay, I'll zoom out a little bit. Here. So this is the border here. It's the 49th parallel out there. It's easy to see. And here we are. This here is Calgary. And this here is Red Deer. So again, Edmonton, Calgary, Red Deer. So if you look at that map, this line here is probably an airspace drop. And if you look at if you look at the legend, you can see the where are they? You can see what it explains. Okay, well, try to find them in your legend.
Is it lower left on the first page?
Oh yeah, that's right. Okay, it's a transponder mode C required. So it's not an airspace, it's a mode C area. So if if it could be a question, what is this line, right? It's a mode C line. So inside that line, you need a transponder with at least mode C. Just and this is Stone Age. Just to let you know, in our gliders we have mode S transponders, so they're way above mode C. Okay, then you see the control zone here, right? And it says, what does it say? Red Deer. So this is what it says about the airport here. It gives you the ATIS frequency. Do we know what ATIS stands for?
Automated terminal information?
Yes,
Something?
exactly. So this is basically a recording that plays, and they update it every hour together with the METAR that tells you basically what the METAR is and all the other things that are happening right now at the airfield. And so and it gives you the pressure and all these things. So before you contact the tower, you should first listen to the ATIS, and every ATIS has a letter. Um, so when you so that they start with alpha in the morning and they end with whatever Zulu. Not sure if they end with Zulu in the evening, but 24 letters later, the end. And so when you call the tower, and you say, this is glider, blah, 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 with information Charlie, for example. Then they know you have gotten the ATIS information Charlie. Then they don't have to tell you that, right? They know that already. Okay, what else do we see here? We see that the control zone goes up to 3000 AGL. This is the control zone. In here, this thing is the VUR. It's not a zone. It just it's an indication that there's a VUR with all the radials. And at this point, because we are out west, the variation is east. Here in Ontario, the variation is west. Okay, so and there's questions to this, and there's questions to what airspace are you flying in when you're flying in here, and do you need a transponder, or what does this say? So you get questions like this, right? Or what is the length of the runway at the Red Deer Regional Airport? What is the length of the runway? The longest runway?
7,500.
7,500. I'm zooming in a little more, and we can see this better. Yeah, there's what you see in the box that shows the airport information is the tower frequency, the ATIS frequency, the elevation. So it's about 3,000 feet elevation. It's pretty high. And then in two digits, the length of the longest runway. That's probably here the north-south runway, the way it looks like, in hundreds of feet. So if it says 75, it's 7,500. That's typical information. When you look at airports on your map, you can find that, and we have questions to that too, right? In our exercise. Okay, so let's go to our exercise, and for that I will stop sharing this. Okay, so the first question we answered already. This was how long is a millimeter, right? We found the SOSA coordinates, and the next one was to find an airport at 42 degrees north, 55.5 minutes north, and 80 west, 45 minutes. And the north and east and west can be either before or after the coordinates. Quite often it's before, like the north and the west. So and the 80 is very often also the longitude, very often a three-digit number. So in that case, it would be 080. So if you see that, don't be confused, right? Just three digits. Okay. The latitude is never more than two digits. What is the highest latitude number we know?
90.
90. What is that? What is it? 90.
North Pole.
Yep.
A lot of ice.
A lot of ice. Yep. And what's at zero?
Equator.
Yeah. So the latitude goes from basically from the equator to the North Pole and to the South Pole. So it's 90 north or 90 south. That's the highest. But the what's the highest longitude you can find?
180.
180. Goes all around. And what is back there? So that's the other side from London, basically. And there's something special back there. What is that? This is when the world becomes really strange.
The international date line
The,
follows
the date line, yeah. So theoretically, the date line should be running exactly on the 180 meridian, but that would make it run through some countries, right? And you can't have two dates in the same country. That's really confusing. Therefore, the date line has bends and goes around basically borders. But back there is the international date line as well. Okay. So coming back to ours, what was the next question? Was find the airport. Who found the airport?
Springfield. Springford or something.
No. Noah found the airport. What did you find, Noah?
I'm trying to find it again to the name. I have all the answers to the questions, but
Okay. Okay. Who still remembers what airport it was? Yeah, Ray?
Tilsonburg.
Tilsonburg. There's a song about Tilsonburg. We had a nationals where everybody landed in Tilsonburg all the time, so there's a song about it. The big sink of Tilsonburg. Okay, so there's Tilsonburg Airport, which makes, by the way, when you do your 50K flight, Tilsonburg is a great place to go to. That's why I picked that. Okay. So then there's an info box beside the airport, right? So on your chart. So what is the field elevation? Yes, Noah.
um I'm still trying to find it, but I'll go by what I wrote, which is 1,220 feet.
No.
No?
885.
Oh, I had 893. Must have saw it wrong.
Yeah, so sort of 2 feet more or less is okay. Somebody said Springfield, found Springfield. Who was that? Oh, Greg. So you must have gotten the coordinates somehow wrong, right?
No, Springfield, I think the town of Springfield is right
Oh,
at that
there is a
coordinate.
town called Springford, by the way.
Springford.
Yeah,
Dave
Springford,
owns that.
yeah.
And yeah, that's really nearby. That's right. Springford is nearby. Very true. Okay,
So
but I was aiming at Tilsonburg. Okay, then runway length
5,500.
5,500. Yes.
Mm.
So can you land your glider there at 5,500? Easy.
Easy, lots of room.
And actually, if you look at that airport, it has this is the longest runway. It's a paved runway, but it also has two grass runways that sort of it forms a triangle, one of those old triangles where they used to train the bomber crews in World War II, right? And if you land with the glider, you may, I mean, if there's a lot of traffic, you should land on the active runway. But if you want to be out of the way, you could land on one of those grass runways because then you're definitely out of the way, right? So you may want to consider that too. But have a good look at it first. Make sure they're mowed and maintained according to the airport information I saw when I looked at it on the internet. Was yeah, they maintain those. But if you feel I'm not so sure the grass looks pretty long there, then go on the hard surface and then try to stop at an intersection where you can drag the glider off, so you're not blocking the entire runway for a long time. Okay. Good. The distance from Sosa,
I got 64 kilometers.
yes, 64. Noah, did you get 64?
I think I was looking at, I don't know why I was going by Springford. I think I got confused, but so now I'm recalculating all my answers to.
Okay, so you were measuring everything. I think there's a little airport. It's Springford.
Yes, that's what I was going by. But
Okay.
now I'm remeasuring.
Okay, yeah, that's fine. That happens. So you got somehow you got the tick marks wrong to find the place, right? That's typically what happens. Or you went the wrong way from one of from one of the 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 parallel lines or the longitudinal lines, right? It can
Yeah, I
happen.
think I was a couple ticks off.
Okay.
and it's just a straight, just ruler, just a straight line from your ruler to the two airports. Is that right? That's all you do, right?
Yeah, you just do a straight line. What is now the straight line? What kind of line is this? This is
Yeah.
another question, right?
Yeah, there's that rounded
So,
one.
what kind of lines do we have if we want to go
You
somewhere?
have,
There's
you
one
have a
that
rum,
just goes at. Go ahead.
you have a rum line and the Great Circle route.
Right. And now, when we put a straight line from Sosa to Tilsonburg, do we make a rump line or is it a Great Circle line?
Rump line.
No.
No. I thought the Great Circle you have to do a hyperbolic, like a curve thing.
Yeah, well, actually, well, first of all, at 50 kilometers, the Great Circle is basically a straight line because it's such a big circle, right? Secondly, if this would be a Mercator projection, right, where all the longitudinal lines are parallel, then it would be a rump line because then your course line would intersect all longitudinal lines at the same angle. But with the chart projections we have here, the longitudinal lines are not parallel. They look parallel, but they are not. They're the slight angle towards the North Pole, right? And so a straight line on that map is it's not quite a great circle line, but it is somewhere between the rhomb line and a great circle line. So it approximates a great circle line to some degree. Not 100%. So if you fly a really long distance, it would be better to map a great circle out. But hey, for gliders, well, some gliders fly 1,000 kilometers, right? But otherwise, for the distances we fly in gliders, it doesn't matter. So yeah, it's just you. What you do is you put a straight line on your map if you want to. If you want to draw it on the map, and then the next thing is, of course, you have to determine what is the heading. Who knows how to who determined the heading? I know Jimmy did. So roughly what heading is it? Just guess, give it a guess.
I had 225.
You had 225, yeah. Okay. I had 227. It's close. So it's basically how close you can measure, right? So good.
Yeah, my protractor wasn't that good.
Yeah. So the important thing is that before you measure out the heading, you should put some thought into what is it. It's basically to the southwest, right? In that direction. So it's got to be between 180 and 270. So if you're measuring, because your protractor does not go around 360 degrees, right? It usually you measure an angle from a longitudinal line, either way. Oh, yours does, yeah. And mine doesn't. But anyways. So then you have to basically do what makes sense. Do we all know which way the lines work, or which way the compass rose goes? I'll put one up here. Just hang on for a sec. There is a compass rose. Okay, so just we understand each other. The compass rose 0 in the north, and N360, 0 and 360 is the same. It's the same tick mark. And then it goes clockwise around. So east is 90, 180 is south, and 270 is west. And then we come up to north again, 360 or 0. So we are talking southwest here somewhere. I mean, we had 227, so roughly in this direction. Okay, so we all understand the compass rose. So when you measure an angle between the vertical line and your course line, you probably get an angle somewhere here or so. And you have to basically interpret this or subtract and add 90 degrees or 180 degrees until it's what it's supposed to be, right? Depends on what you measure the angle of. You should always measure the angle of one of the longitudinal lines. But the typical protractor only goes to 180 degrees. So you have to add and subtract. And therefore, it's good to know roughly where you should be ending up. Is any of you a sailor? Sailors come forward. Yeah, Ray is a sailor. So this is and Doug too. So you know all about this, right? Okay. Okay, so next question.
Can I ask a question about the heading?
Yes.
So the question asked for true heading. So you based your measurement on the lines of longitude to determine that heading as 225.
Yes.
But if we determined it by true north, it would be different, correct?
No,
Like if it's magnetic.
magnetic is not true north. True north,
No, I mean, yeah, I didn't mean to say true north. So true north uses
yeah,
the longitude lines,
right.
and we get a number of 225 true north.
That's
But if
right.
we fly, you fly by a compass, right? So
That's
wouldn't
right.
we use the magnetic heading,
Yes, we
which
go.
would be
Yeah.
232, I think.
Yes. So what we do is if we determine a heading, we start out with the true because that's what we can measure out of the chart, right?
Okay.
And then we convert it into a compass heading. So that was the next question, right? Convert it to a compass heading.
Oh, okay.
And
Okay.
deviation is 2 degrees east. Do we know what the deviation is? What that means?
That's your compass correction from true north.
That's that's the compass correction. Yeah, that's the compass correction from not from true north. It's the compass error. It just this compass has, and from magnetic north actually.
Okay.
And then you probably noticed that I didn't give you a variation. Why didn't I give you a variation? Because it's on the chart. So when you look at your chart, there's variation lines. They look like, okay, I'm going home here with my chart. Oh.
I see it there. It's around 9 degrees west, around near Sosa.
Right. Right. Let me just find a chart here, a proper chart.
It's down near the edge, the bottom edge, the numbers.
Yeah, yeah. This is another number. If you follow the line, these are sort of little broken lines, and you have to follow it where the chart is not busy, and then it shows you, right? Okay. Let's open this chart here. There you come. So here's my chart. It's a little outdated chart, but anyways. Okay, so you
Look down
see,
Lake Erie there, yeah.
yeah, you see this line here? Can you see my cursor there? And this is one of those variation lines. Another one is, I have to zoom in a little. Okay, so here's a variation line. This is the 9 on my chart. It's an old chart, so it may be different with you. It's a 9-degree west variation here. And that pretty much goes, where's Tilsonburg? Tilsonburg is here. This is the town. This is the airport. Okay, and then there's another variation line over here. This is the 10 degrees. So it's growing basically from left to right, the variation. Okay. And while we're just here at Tilsonburg, we can also look at information. See here, this is the Tilsonburg airport information. There, this is where it says 8085, the elevation, right? And it's an old chart, so it's 40 A, means 4,000 asphalt, but in the meantime, it's 5,500. So it has been updated. So, but this is where the airport information is contained. And it's a little bit away. There's a line that points to the airport. The airport is just, it's too busy here. So that's why they put it away a little bit, because we have airspace going and all sorts of things. Okay.
So
You can see, you can see Springford there.
So I thought Springford was the airport, but I didn't see that line there, so I just thought it was close.
Okay. Yeah. Yeah. So yeah. Okay. So you found this airport, but you thought it was Frankfurt. Yeah, quite
Yeah, and
quite
so
correct.
I have to see. There's always a line there that goes from there. Is that right?
Yeah, yeah. There's where it says which airport it is. There's a line that points toward it, unless the name's right under the runway or so, right?
Okay.
And I mean, it didn't even occur to me because I mean I've been there many times. I know here down here's the town of Tilsonburg. And I know the runway is a bit north of the town, right? So I haven't really. Frankfurt is just a hick town, right? But for example, we can look at if we look at this airport here. This is Staffordville. This is the box here. Staffordville pertains to this airport. So now there's no line because it's right beside the thing here, and it has 782 feet elevation. 20A means 2,000 feet asphalt runway. Okay, interesting. Doesn't look like it has an asphalt. Then a bigger airport would be
St. Thomas there.
yeah. There's St. Thomas here. It's St. Thomas. See, that's the box is up here, and there's a line down to the airport. And so this box actually gives. There's also a radio beacon there. So this box gives the information about the radio beacon, the frequency, and the identifier. And the airport box is down here. And zoomed in so far that it's hard to read, right? But I can see the elevation 778. You can probably see this much better on your maps than I can show here because this is just a photo of a map, right? Okay. Any questions about this?
Just on the heading, so we determined the heading was around 225, 227 true.
Yes.
And as Ray said, magnetic would be 9 degrees west, right?
Yeah.
So that would be a plus to that.
Yeah. Remember, west is best.
Okay. And then, but our deviation is 2 east, so that would minus 2 from that number.
Right.
Is that right? Okay.
Mm-hmm. So I end up with 234 compass. And I mean, plus or minus 2 or 3 degrees. This is basically how we measured it. Okay. So next question. If you fly at an average cross-country ground speed of 60 kilometers per hour, how long is it going to take you?
Just over an hour.
Just over an hour. Yep. Yep. That's right. Jimmy figured it out, so it's an hour and a few 3 or 4 minutes or so. Okay. So you're flying a junior with the best LOVD of 33. You're 15 kilometers away from your destination and you're 4,500 feet MSL. Can you make it? When there's no wind, if you start your final glide now, can you safely make it?
I said yes, with
Yeah.
quite a bit of room.
So what made you say yes?
Well, I drew a little diagram with, so I was at 4,500 feet. Tilsonburg's at around 900 feet. So
Yeah.
my high key area would be around 1,700 feet. 15, was it 15 miles? 15 kilometers. So I
15
figured,
kilometers, yeah.
right, I figured that out to how many feet. So I could do it if I had 2,800 feet to drop in 15K.
Mm-hmm.
Does that
Okay.
sound right? So that's how I figured I could make it.
Yeah, yeah, that's right. You can, I mean, the question is, can you safely make it? And the question is, what is safely? Safely is, in my mind, that you arrive um, at least at the pattern altitude, and ideally with maybe 500 feet to spare. Let's say if you, but from 4,500 you do. Do you all know the rule of thumb for final glides? Who has ever heard about the rule of thumb? It's a very simple rule of thumb. 1,000 feet per 10 kilometers. How's that? It's easy, eh? And that sort of is a glide ratio of 33 to 1. Now, if you're flying an airplane like the Discus 2 or so, um, a faster airplane and a better airplane that has more than 33 to 1, the Discus 2 has about 42 to 1 or so, then you're pretty safe with that one if you go 10 kilometers per 1,000 feet. If you fly a junior, it's a little dicey because this is just your best LOD, right? And you're not really sure if you get the best LOD, and there could be a little bit of wind or so. But somewhere in that range, if you apply this and you say 15 kilometers should take me about 1,500 feet, then I better put another 500 feet on just in case I don't make my best LOD. So 2,000 feet. Then I arrive at 2,500 feet roughly. That's still pretty good, right? So that's how you can do a rough, and you should always do this. Never, if you have a fancy final glide computer that figures it out to the last foot, garbage in, garbage out. Don't trust this thing without doing the well. Let's quickly do the rule of thumb, right? And if the rule of thumb roughly agrees with your final glide computer, it's good. If it vastly disagrees, don't believe this thing, right? I almost landed out with the DG505 years ago because the final glide computer told me, you can make it home easily, right? And I was over Paris there. And then when I got to maybe 8 kilometers out of Sosa, I really, really needed to do a low save to make it in, right? So it was for the person who was flying with me. It was actually she was a student at Sosa at the time. She had a ball because she had never experienced anything like it, right? She was sitting in the back seat applauding here, and it was really. I mean, we had our field picked to land in, but in the end, we just very slowly at first managed to climb away from there and make it home. But so don't necessarily always believe your fancy final glide computer. The wind could be set wrong. The arrival height could be set wrong. There is a lot of things that can be set wrong in a computer which you don't normally see. That or the MacCready could be set wrong. That can screw this up. So always do the rule of thumb thing before you actually commit to a final glide. Okay, so this goes for your 50K. Okay. So now let's say you arrive at 2,000 feet over the airport. What class of airspace are you in?
This is my weak point. I could not find it.
You could not find it. Well, what is the standard height of airspace, controlled airspace above the ground? For example, at airways, right? How far do airways go down above the ground? I will find something for you. My computer is really slowing down. Did anybody else find what airspace it is in? Jimmy found it, right? So Jimmy, how did you know the airspace?
So on the front of the map in the legend in the bottom left, it shows the icon, the line that says control areas with different floors. And it says floors are 2,200 feet AGL in Canada unless otherwise indicated. I didn't
Yep.
find an indication, so then it must have been Class G.
Yes. So just a second here. So this is our, you should have this. This is our airspace thing. Okay, so Class G is the uncontrolled airspace. And so out in the prairies, somewhere it can go fairly high, right? But here where we are, below low-level airways, and whole southern Ontario is basically, there's so many airways that they basically made the whole Class E airspace down to the bottom of the airways. So everything is 2,200 feet, unless you get closer to an airport, then it drops down to the famous 700 feet above ground. So it goes from 2,200 to 700. For example, it's also at 700. So how can we see that? Let's look at the chart again. Where's our chart here? You see this line around London here, and it says E700 in there. That means Class E goes down to 700 feet. That means outside this line there, it is 2,200, and we are, remember, we are in Tilsonburg, so we are here. Then here's another line. This is the line that goes around Toronto and everything, and it says inside that line 700 feet. And Sosa is here. We're inside the line. And if you look at it, this is a big line. See, it goes around all the way here. And then
on our maps, on the newer one, there is a line. There's a bunch of lines right. Actually, Tilsonburg is right on the edge. I can't remember if it was quite in, and then there's no, I can't find any E or G in that line, but I don't know.
okay.
Did you see anything in there?
Mm-hmm. Okay. Maybe Doug, if you could think.
Tilsonburg was right on the edge of that circular line.
Oh, that's the Toronto class.
Right.
That's the Toronto transponder mode.
Okay.
See that? Is it
Yes.
is it this line here?
Right, but now on our map, there's one that comes out and goes right through the city of Tilsonburg, but it's sort of the airport at Tilsonburg is like right on the edge of that, so that's what confused me. But I understand what you're saying now.
Mm-hmm. Basically, what it says is that from here out, not in the old days, right? This is probably changed. From here out in to Toronto, you need to have transponder. You have to have a mode C transponder above 6,500 ASL. Now, I would think nowadays this is lower, right? But this is basically a mandatory transponder line here. So this line, the transponder line, is a smooth line. The ragged lines are basically floor changes in controlled airspace. So the floor changes, the standard floor here is 2,200, and it drops down to 700 here, and it drops down to 700 here, but in between it's 22, and it's 22 above ground. So at 2,000 MSL, you are still in Class G uncontrolled airspace.
Yep, the Toronto line, the Toronto transponder line's still the same on my map, but there is another jagged line like the one around London that comes just goes straight east.
Okay.
There's a little triangle there where the Toronto line and right where your mouse was, and it just cuts straight across, um, goes right out into the lake actually to is that Simcoe out that way? Even past, but yeah, there's another line there anyway. So
Okay.
that's
Maybe if you could take a photo of that and send it to me,
okay.
just of that area there, right, with that line on it. I guess I shouldn't be cheap and I should buy myself an up-to-date map. Sorry, guys. Okay. So next
Just a
question.
question. Just a question that transponder mode C requires that at 6500 ASL. That means if you're above 6500, you need to have a transponder mode. What does that exactly mean?
Yeah, it means if you fly in there, like if you're flying towards Toronto and you cross this line, and you're higher than 6500, you need to have a working transponder mode C. But
What's that?
gliders are exempt.
I'm
So
sorry.
gliders are exempt.
Oh, okay.
So
All right.
gliders are still exempt of transponder requirements because, well, there's a battery issue, right? If you run a transponder, of course, nowadays the technology has caught up with things, and the modern transponders they're not as power hungry anymore as the old ones. So we have now the latest and greatest in transponders in the gliders, which are Mode S transponders, and they give a lot more information than a Mode C transponder. They can basically, the radar guy who looks at us can see who the owner of the airplane is and end. Back then, when this map was published, there was nothing better than Mode C. But still, a lot of power planes, like all the Cessnas that fly around Zosa and so, they all fly with Mode C transponders. If they would fly with Mode S transponders, we could see them on the floor. That's the beef I have with them. You should upgrade a little. It's the 21st century, after all. Okay, so we had another question there. And the other question was, if you arrive higher, you arrive at 3500 MSL, what airspace are you in then? We are in controlled airspace, in Class E airspace, because the floor, remember, is 2200 AGL, which makes it 3100 or so MSL. So at 3500, you're in the controlled airspace, and it's Class E airspace. If it's not a control zone or something, then it's Class E airspace. And then the question was, what is the minimum distance you have to keep from clouds vertically and horizontally in Class E airspace, controlled airspace? That's something you need to know.
I think it's 500 from the clouds, and it's 3 miles.
It's no, it's 500 vertically and 1 mile horizontally. Let me check if it's with the 1 mile. I'm not so. It's either 1 or 2 miles, but we can look this up easily. Okay, where's our? There we go down here. This. So you all have this airspace thing, by the way. I sent this out a long time ago at the beginning of the course. Consult it frequently. It condenses the whole airspace into a really good document. And down here are the basic VFR weather minima, controlled airspace, cloud, 500 vertical, 1 mile horizontal. Okay, and there will likely be a question about that, but about the minima for controlled airspace or uncontrolled airspace, right? Uncontrolled airspace is clear of cloud, and uncontrolled airspace below 1000 AGL, you need to see 2 miles. If you're above 1000 AGL, oh no, uncontrolled is actually when you're a little higher, it's 500 feet vertical and 2000 feet horizontal. Sorry for that. And but you only need to have during the day, you only need to see 1 mile, which is really close, and we don't fly in this kind of weather anyways, right? And where we fly, there is basically no uncontrolled airspace, because how high does the uncontrolled airspace go at Sosa?
6 or 700.
700. The flip is at 700, right? Remember, Sosa is within that 700 Class E thing that goes around Toronto. So we are basically, as soon as we are above 700, as soon as we are in controlled airspace. And I mean, we're only falling out of it basically on downwind as we are getting ready to land. So we always, this kind of minima don't really apply to us. We always need the 3 miles and the 500 feet and the 1 mile horizontal. But you also need to know sometimes the uncontrolled. There's questions about, it's usually a question either about controlled or uncontrolled airspace, the minima. So you should know those. They're important. Okay. So that was all the questions, I think. What did I have? Another one?
No, you had two
Oh, yes.
fine things that all over the map.
We had the C, the controlled F, the controlled airspace, the class F airspace. Right. Who found that?
That was around the Rideau Canal area. Is that Rideau Class F special? And there was
Yeah,
gliders or something.
yeah. That was one, but there was another one.
There was one that you
Found
had like West 079. Well, I didn't understand that 079. Was that zero supposed to be 0 point? Would that be like that zero in front of the 79 bothered me. What does that mean?
That's just the added digit. Remember earlier I said it could be 80, like the longitude, right? Has normally 3 digits, or can have up to 3 digits.
Oh,
And
okay.
quite often the zero is in there because as the third digit. So 079 means 79. Okay, so it
Because it's
was.
not all. Other times it wasn't there. It was just 79. Is the zero always there?
Sometimes it's there, sometimes it's not there.
Okay.
That's
Thank you so much.
that's why I put it in to point this out, right?
Yeah,
To
yeah. You
confuse you
confused me.
basically.
Okay, thank you.
Okay, so what is the airspace? The airspace is the Borden, base Borden. And base Borden is here. It's this airspace here. See that? And what does it mean when the airspace is, when it's the edge is hatched like this? What kind of airspace is it? Look at your legend.
I think it was F.
is that F?
That's a Class F airspace, yeah? It's a special use airspace. And what kind of Class F airspaces do we have?
So it's CYR.
Yeah, so this one is a, see this up here? CYR 502. And the CYR means, the R stands for restricted. That means don't go there. Can't get in. You need special permission to get in there. So
And what is that CZE up just above there?
It's a Class E control zone. That's this control zone that goes around it. See that? The round thing there? And it's Class E.
Okay.
And there's gliders. There's where the cadets fly, right? That's why there's a glider. But it's a base. It's a military base as well, right? So that's when it's hatched like this, it is Class F airspace, and then it depends on what it is. They always start with CY in Canada, and then there can be an R, there can be a D. D stands for danger, quite often when there is blasting or so. And there can be an A, and an A is advisory. And then there's many different kinds of A's. And this is all when you look at your map. Okay, I'll show you a map here. Okay, it is down here. Now, where's my finger? It doesn't show up. So it's basically in the front page of your map, the legend, pretty far down, about a quarter down. That's where it is. Okay.
Oops, sorry. I did send you a email with that, with Tilsonburg on it.
Okay. Let me have a quick look.
And my screen is locked up, so I'm fighting with that.
Okay. Yeah. Um,
No, I can see you guys. It's just my camera's locked up. That's all.
yeah. Okay. Okay. Just give me a moment here.
I sent it to a Hotmail.
Yeah, I have it. It's just with that with the Google Meet going, my computer is really slow, right? It's coming down to okay. So we'll close this. We'll go here. Okay, so can we turn it? No. Okay, Tilsonburg. Okay, okay, so what you see here, you mean this line here, the right?
Yeah, that's the one that was confusing me. It was going into the London one.
Yeah.
And I couldn't find any E's or any altitudes or anything in there.
Yeah. I'm not quite sure what it is. It can't be 500 because let's see, is the London still saying E500 here inside London?
Yes, it still says E500 inside London.
So it must be higher than 500, right? So it's the next step higher than 500 is 2200. So I guess that's what it is. So maybe out here it's a little higher still. Okay, but difficult to say. Okay, so But we were at the Class F airspace, so we'll close this. Thank you for sending it. And we go back here. And now, so we were at the Borden airspace, base Borden there. And the next one is the Rideau Valley. And I need to change maps here. Okay, that's not the one. No. Okay, I don't have a map that goes all the way out to the Rideau Valley. So you tell me what you see and read there.
I think it was class F and special use. I think it was for gliders.
It is for gliders, yeah. So let's have a look at this. Okay. So Rideau Valley this is Ottawa here, and the Ottawa airspaces. And the Rideau Valley is here. Here. Okay, so what kind of Class F airspace is it?
Special use.
Special use, yeah. So what is it, an advisory area or is it a danger area or what is it? Or
An advisory?
It's an advisory because it says CYA, right? And then it gives every special use airspace, like every Class F airspace has a number. And there's actually a book, you can look them up. So, and behind that, most of the Class F airspaces are advisory airspaces. Behind that, it says what it does. And it says S for soaring, and it says T for training. And if you look at the legend of your chart, where these Class F airspaces are explained, that's on the front page there. There's a whole on the right side of that. There's a whole area about explaining what's what and what the various various letters mean. Right. Quite often there is a P is parachuting. Right. It's pretty common. S is gliders, soaring, and so on. And then here, what is this airspace here?
Restricted.
It's a restricted, yes. And so that's basically an airspace we better not go in there. I think there is an old there's an old military. I think there was from the Cold War. There is an underground bunker where all the politicians in Ottawa disappear if there's a nuclear war or something like that. Then there's others as well. For example, this guy here is a very small one. Could be there's one like this over Kitchener as well, and it's a prison. This could be a prison, right? And this it could also be some kind of a wildlife area where you're not supposed to go. And again, with that number, everyone has a different number. With that number, you can look them up. what's really happening there. And okay, I guess we beat all that one. Any other questions to maps?
Can you show us when you? I remember you showed us how to the what's the word I'm thinking of? You had to figure out what direction to fly the um, the compass headings again, and how you figured out for that particular flight path. How you figured that was 220 or something? I couldn't figure that part out again.
Okay, yeah, we'll go back to that. So we're going back to Tilsonburg. Okay, so this is a little bit of an easier map to look at. Here's the Tilsonburg Airport. Here's the Tilsonburg town. So I basically took a ruler and put it from Rockton to Tilsonburg. And first of all, with that ruler, I measured the distance. And it came out to about 130 millimeters, or 128 millimeters.
Yep.
So so with that, I calculated what the distance in kilometers is. We know that 2 millimeters is a kilometer, so 60. This is how our 64 kilometers came about. And the next thing is I took my triangle here. This guy here again, and I measured the angle between. I found a nice longitudinal line, and I basically measured the angle between that line and my ruler that was still there, right? And it came out to something like a little over 90 degrees, right? So, and whatever I measured there, well, actually, my triangle has several markings, and I could just read the 300 the 230 whatever it was 22 the 222 or so off the marking. But if you're measuring just the angle there, then you have to, because from the north it goes this way around, you basically have to take this angle and subtract it from 360. So whatever you measure there, let's say you measure 120, 100 degrees, maybe 110 degrees, right? And my guess right now, right? It's more than 90. It's less than 180. It's closer to 90, so about 110. And you go 360 minus 110 is 260, 250, yeah. And it is in reality, it's 222. But this is how you basically go with whatever you measure here. You then take 360 on this side. If you're on the other side, then it is actually a compass measurement you have, right? Because the compass starts going from this side all around 90 degrees, 180, 270, 360. But your triangle or whatever you use normally for a protractor doesn't go more than 180, right? So you basically have to measure it from this side. And then you have to basically subtract it from 360. Easy, right? Everybody understand? Noah? Yes. Good. Okay. Good stuff. Any other questions? Then see what we else wanted to do. Okay. Yeah, so the other thing I still wanted to do was Okay, yeah, quick recap. Well, because we are just at the lines of that showed the variation, right? The 10 degrees or 9 degrees there down here. What are these lines called? Here, this line here, the variation line. What are these lines called? They are they're called isogones. Remember, they're gonic lines, and a line of equal variation is called an isogone. And so there's one here, there's another one here. That's the 10-degree line, right? Can you see that? And where does it say 10 degrees? It says here 10 degrees west. Do you see that?
And what is the zero line called?
The zero line is called the prime meridian.
I'm sorry, no, the variation where it's zero variation.
Oh, where the zero variation. Oh, sorry. Of course, the zero variation is called the agonic line.
Agonic and the others are
Isogones.
I,
Do we still know where the agonic line is?
It's Greenwich.
No, that's the prime meridian in Greenwich.
I think that the agonic line and the prime meridian is on the same place right now since 2019.
no, it's close to Winnipeg or Thunder Bay, isn't it around there somewhere?
Yeah, there's probably one on the other side of the world as well. I know that the variation in Europe is pretty small because we are that much further away from the magnetic pole, and the magnetic pole and the geographic pole, they line up, right? In both directions. They line up going south, and they line up going north and coming around the other way, right? And on both sides is an agonic line. So let me just quickly find a picture to explain this. Okay. We have a nice picture for that. But I can't find it right now. Oh, there we are. Okay. So this is the variation here. I'm going out a little bit. And what's causing it? The variation is caused by the fact that the North Pole, that's the geographic North Pole and the magnetic North Pole, are at different locations. So when we are in eastern Canada, our compass points quite a bit to the left um, from the true north, right? So the needle points this way when we are actually looking at true north. And it's in eastern Canada, this is 27 degrees west. And it is west, 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 west. And then where the poles are in line, about here, this is the agonic line. So in our area, it's 10 degrees, roughly 10 degrees west. So it's quite a bit less. And it gets less, 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 less until about here. And it's zero. So if you look up You go up this longitude line here.
About Saskatchewan there, I guess.
Yeah, it's somewhere in Saskatchewan there. And then as you go further, then the variation becomes east. When you're in eastern Canada, then you have about 20 degrees east. So you go from 27 west to 20 east, but it's got to go through zero somewhere. And that's the agonic line. Makes sense, doesn't it? Okay. So if there are no more questions to charts, etc., let's revisit some weather. How is that? And I'll bring up. Okay, I have it already open. And since I have it open, there's something else I quickly want to show you before we go to that. And that is one question that was frequently incorrect was what happens when you're on tow and airspeed is too slow. Okay. And where is that now? No, if the airspeed is too fast, you yaw. If the airspeed is too low, if you want to signal to the tow pilot to go faster, you can rock your wings. And I think on pretty much everybody got this wrong. Personally, I mean, we have all radios. Obviously, if somebody said I release immediately, not a good idea. It depends on how high you are. Right? If you're really low, releasing, particularly if you're already too slow, it gets you into the trees really quickly. Um, if you have a radio, you just say faster. Don't argue about what the speed is, and so just say tow pilot, whiskey Yankee, faster, and then see if he speeds up a little bit. If you don't have a radio, the signal for gliders, and this is not in the normal signaling things I have seen, is basically rocking wings. That means increase the airspeed. If the tow plane is going too fast, sort of yawing back and forth with your rudder, basically wiggling the rudder, this is how you signal it's going too fast. But the common thing is not so much in our training, but in competitions when the gliders are heavily loaded with water and the tow pilot hasn't been briefed properly that the glider is hanging there and is too slow, and you hear the pilots call on the radio, faster, 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 and some tow pilots are arguing and so on. This is the normal thing. But the signal, if you can't do the radio thing, then you rock your wings. That's the signal. And there was one question, and I think it's one of the questions everybody got wrong. Okay, and the important signal you need to know, there's two really important signals that are more important than everything else, is when the tow plane rocks the wings, you have to release, right? Here, glider release immediately. And if the tow plane wiggles the rudder, it's not in there, that means check your dive brakes. Your dive brakes are open. And the reason why those are so important is because you don't want to confuse them. People have confused them. The tow plane was wiggling the rudder and they released and were in big trouble afterwards because they also had the dive brakes open. So know those two. Tow plane rocks the wings, release. Tow plane wiggles the rudder. Look at your dive brakes. They're open, right? This is what you need to know. They're the two most important signals on tow, and really for your own safety, please remember those. They have a practical relevance. The others, well, not so much. Like yeah, there are signals if you cannot release and so, but A, you have a radio, and B, toast hooks don't fail. I've never seen a toast hook fail. So
Question about going too fast or too slow. What type of speeds are we talking about, and what would be happening?
well, too slow is when you start stalling, right? When the glider gets really mushy, right? And it can get so bad that the glider drops a wing and you just cannot control it anymore, right? And then you have to release because otherwise you're going into a spin and you take the tow plane with you. When it too fast is every glider has a maximum tow speed,
So in the red,
which you should know, right? But
yeah.
it's unlikely that you will ever get there. The modern gliders, I mean, the old gliders, they were basically kites, more or less. You could tow them too fast, but an ASK 21, I think that has a maximum tow speed of something like 97 knots. So you never go there, right? It's academic, but too slow. I mean, when you start feeling the glider is the nose is getting pretty high, and so on, you have trouble even controlling the glider, right? Then it's important that the tow pilot speeds up quickly, right? Because otherwise it gets really bad. But it doesn't happen. It's unlikely to happen with a K21. It's likely to happen with a fully loaded ASG 29 or so. Okay, so weather. So I just wanted to quickly bring this up. And well, we have 9 minutes. We can do a few. Where is my weather? Yep, this is the one. Remember the TAFs and the METARs and all the abbreviations and so. Okay, let's look at this METAR here. Question number one, for what airport is it? Who knows the answer?
CYHM, whatever that means.
That means Hamilton. It's for your Hamilton. Okay. So it's a Hamilton airport. So there's the two airports that are important for us is CYHM, Hamilton. Do we know what Kitchener is? CYKF. So these are the two important airports. Okay, so what does that mean?
On the 5th at Zulu time 1800.
And the 5th at 18 Zulu. What does Zulu time mean?
That international time that we all have the same time frame around the world.
Yeah, is there another name for it?
Greenwich time or Zulu?
Yeah, the official other name now is UTC, Universal Time, but the Brits still say Greenwich time. In the old days, it used to be GMT, Greenwich time, Greenwich Mean Time, actually. The Brits still refer to that, but internationally it's called either Zulu or UTC. Okay. What does this mean?
That's your wind information?
Yeah, that's the wind.
240 degrees, from 240 degrees, wind speed 18 knots, gusting to 29.
Right. Good stuff.
And you
And
can see visibility over 10 statutory miles.
yeah, visibility not over, but 10. If it were over, it would be a plus or so.
Great.
And what does this mean? We'll ask
That's
Noah.
oh, go ahead.
Noah, can you tell us what this means?
That's your cloud information. So
That's that's the clouds, yeah. So it basically means few. So that's not an abbreviation, that's real. So there's few clouds at what height, Noah?
I'm trying to find in my notes, but then I guess.
At 3,200.
Okay.
So the heights are basically always in hundreds of feet. Okay, so few clouds. What does few mean? How many clouds are there?
I'm not sure.
Well, it's as it says, few, so it's 1 octa. Remember, we do the clouds in octas. It's 1 octa or 2 octas. Okay, so then we'll ask Brad. What does this mean, Brad? Brad, did you hear me? Yeah. You have to turn your microphone on. Yeah, you
you're
have to.
muted, Brad.